In the space of science and colossal inclinations toward pieces of information, the subject of what existed right off the bat to the huge impact has blended conversations and dazzled characters for quite a while. This Goliath request doesn't just test how we could unwind the universe. It challenges the genuine farthest targets of human data. Envision standing at the edge of existence, reviewing the monstrous shadowing and taking into account what lay there before our universe was imagined. The event of the Big Bang meant the start of history, space, and what we know. Regardless, there was a moment sooner, early this May. There, in the end, may have been a condition of nothingness, a calm before the fuming gathering started. And, assuming this is true, was it? Or perhaps there was something generally more upsetting that existed before time itself. As we hop further into this question, science takes us on a journey past the universe's beginning stage into considerations that challenge our comprehension. Physicist Brian Cox, known for his obligation to the miracles of the universe, suggests that something shocking might have existed before the Big Bang. He moves us to rethink our understanding of the world and existence. In this evaluation, we'll explore the science, the speculation, and the astonishing insider mysteries that could sort out what existed preceding all that. We'll investigate assessments like steadfast improvement, quantum changes, dark energy, and, surprisingly, the multiverse. The responses we've uncovered might just confound you, but they could also open new understandings of our circumstance in the universe. Plan to plunge deep into a world beyond imagination. Science, where the dark still winds around the shadows, leaving specialists staggered and at times even stunned. We should analyze what existed before the Big Bang and why these hypotheses challenge all that we expected we knew. To appreciate what could have existed before the Big Bang, we first need to look at what the Big Bang truly was. The Big Bang, as scientists describe it, was the event when the universe became strikingly hot and dense, rapidly expanding to set off the development of all matter, energy, and limitless forces. When we look toward the night sky, we see proof of this hot beginning, with galaxies spreading out from a starting point. However, what made this happen? Was there a time before this thick, hot start? As shown by the hypothesis of cosmic inflation, there was, for sure, a before, and it was an almost empty or quiet state. Cosmic inflation suggests that, beforehand, the universe was in an express that was cold, vacant, and free, basically like a motivating vacuum. Regardless, the vacuum wasn't absolutely unfilled. It contained a gigantic amount of energy that controlled the quick expansion of space itself. This expansion happened so rapidly that it essentially settled the justification for all that would happen in a portion of continuous space. It reached out at stunning rates until the expansion slowed down, and the energy turned into particles and the forces we think of in the Big Bang. Yet what was the nature of this energy? Why did it, from nowhere, energize the universe, and why did it stop? Scientists believe this boundless expansion created patches of the universe, each experiencing its own Big Bang. Envision a surface enlarging perpetually, with short-lived fuel bubbles forming. Each bubble represents a universe, including our own. This thought, called the inflationary multiverse, suggests that there are possibly unfathomable Big Bangs and a limitless number of universes. Our own is only one of many. This tremendous, marvelous reality challenges how we could interpret the very universe itself and leaves us with a question. What else is out there? The possibility of nothingness before the Big Bang is theoretical, not real, at least according to our current understanding. Whether or not you eliminate all energy, particles, and radiation from the universe, it would still not be truly void. Our universe is filled with dark matter, dark energy, quantum fields, and other forces that we've yet to fully understand. Even in its most empty state, the universe still holds something. Even if we imagine stripping away these forces, leaving a dead space, the universe would still produce new kinds of energy. This reality is confounding to scientists, as it suggests that true nothingness might be unimaginable within our current comprehension of space. Space itself has properties, rules, and constants that prevent it from being absolutely unfilled. Imagine creating a region with literally nothing in it. No particles, no radiation, and no negative energy, except for quantum fields and massive constants. These would still exist, suggesting that this nothingness has properties. For instance, there's a theory called zero-point energy, which represents the most immeasurable energy state of quantum fields. In this state, particles can still appear and disappear, creating an unnerving echo of change, even in what should be empty space. This challenges our idea of a true void and suggests that even before the Big Bang, there was something. Researchers are still studying this, and one of the most astounding theories in current cosmology is the possibility of eternal development. If inflation could create our universe, it's conceivable that it could continue forever. Brian Cox describes an incredibly vast inflationary multiverse, where universes are continuously created and evolve. Imagine each Big Bang as a flash lighting another universe, while inflation happens in different regions, creating countless other universes. This process could, in theory, happen forever. This idea of enormous universes creating others leads to an intriguing concept of a fractal universe, where each new universe may actually create its own Big Bang. Each universe exists as an entirely separate space, unaffected by the others. For researchers, this hypothesis is both exciting and unsettling, as it suggests a persistent multiverse with no clear beginning or end. Imagine our universe being just a part of a massive cosmic design, constantly creating and continually making new universes. What if that's the true essence of reality? There is no before or after, but perhaps an eternal pattern of universes forming. How we interpret nothingness changes when we understand this. Consider the quantum field hypothesis. As shown by this hypothesis, the universe isn't just a mix of issues drifting in space. Perhaps it's a convoluted relationship of energy handles that fill the universe, interfacing with all that we notice. These fields resemble unimportant seas, with particles going about as waves or aggravations. In any event, when fields are at their basic energy level, known as the vacuum state, they are still active. Particles can appear and disperse in these fields, immediately getting energy before returning it. This characteristic leads to virtual particles, substances that briefly exist and then dissipate, leaving only a weak memory of their presence. The concept of virtual particles challenges the validity of a certified void. Imagine an unfilled universe where all matter, radiation, and energy are wiped out. Would you have, as a matter of fact, nothing? According to the quantum field hypothesis, you wouldn't. Even in a vacuum, fields would stay dynamic, sometimes making transient particles. This steady movement in what ought to be nothing suggests that the universe doesn't adhere to our idea of void. The fields and forces keep filling the universe with private energy that prevents absolute nothingness. This raises a dazzling issue. If fields make particles and particles make matter, might the real universe have risen from this nothingness, filled with quantum fields? Dark energy is an odd power that currently drives the accelerated expansion of our universe. However, did dark energy exist before the Big Bang? According to some viewpoints, the fact that dark energy exists today is a deferred result of an energy field from before our universe's development. The properties of dark energy imply that a vast, mysterious power might have existed in some form before the Big Bang. Some theories suggest that dark energy, in a much stronger state, may have controlled the inflationary stage, causing rapid expansion. The presence of dark energy suggests that whether or not our universe was purged of all matter and radiation, this power would continue to influence the outer layer of spacetime. This thought leads to an unsettling question. If dark energy was present before the Big Bang, might it have, at some point, formed the conditions that led to the creation of our universe? Might dark energy be the quiet designer of expansion, or even the true beginning of our universe? As we explore this possibility, we face the potential of dark energy not as a force shaping our universe, but as a key that could unlock the secrets of the multiverse itself. Another theory is that cyclic cosmology offers an alternative to the Big Bang as a definitive beginning. This hypothesis suggests that the universe goes through enormous cycles of birth, death, and renewal. In this model, the Big Bang is not a one-time event but perhaps part of an undying cycle, where universes form independently and then revive in another cycle. This hypothesis proposes that our universe may have been restored from the remnants of a past universe. The process of compression and expansion in a cyclic pattern would imply that there was never a real beginning, but instead a timeless series of universes arising and restoring themselves repeatedly. Cyclic cosmology raises critical questions. Never a better time than right now, suggesting that time itself could repeat rather than continue. If this theory is correct, it could imply that what existed before the Big Bang was simply another form of the universe, one that collapsed solely to give birth to our current universe. For scientists, this hypothesis offers a rich answer to the question of extreme beginnings, suggesting that there is no clear start. The universe has always existed in some form, transcending our concepts of time and existence. Gravitational waves are another intriguing concept that could shed light on what existed before the Big Bang. These waves, discovered in 2015, are ripples in spacetime caused by incredibly massive objects, like black holes or colliding neutron stars. These waves can travel great distances, carrying information about the events that created them. Could gravitational waves one day provide insight into the creation of the universe? A few physicists suggest that gravitational waves from before the Big Bang could offer clues about the state of the universe before inflation began. Gravitational waves from the early universe might leave traces that could help us understand whether the Big Bang was really the start or whether there were vast events before that, which we don't yet comprehend. These waves could be remnants of events beyond our usual understanding. Their presence could also suggest a greater structure beyond the one we are familiar with. These faint signals could open insights that could alter our perspective. Just as we uncovered the Big Bang's beginning, consider how possible it is that they show the faint hints of a past universe or an event that happened before the Big Bang. As researchers continue to probe the deep reaches of space, the question remains: what existed before the Big Bang? With current theories highlighting quantum mechanics, multiverses, and cosmic evolution, it seems we are closer than ever to unraveling the deep secrets of the universe's origins. While the complete answer remains elusive, our understanding of what existed before the Big Bang continues to evolve with each new discovery. As we explore these theories, we can also consider how they might fit together to reveal the larger picture, the true essence of existence itself. But until then, we are left with a mystery driving science and wandering into dark spots far beyond what we have yet learned. We continue to dig into the mysteries of what existed before the Big Bang. Of course, how we understand the universe is constantly evolving. One key area of investigation involves the relationship between existence itself and time as we experience it. Time might not have existed in the way we understand it before the Big Bang. Some theories suggest that time, as a concept, began with a Big Bang, making it impossible to trace what came before. This idea challenges our fundamental impression of existence, suggesting that the question of before may not truly be relevant when it comes to the universe's beginnings. In addition, later advances in the study of quantum mechanics have sparked groundbreaking ideas about the nature of reality. One particularly captivating idea is the possibility of a quantum vacuum, a state where, even without matter, the universe is not truly empty. Instead, it is filled with fluctuating energy fields that can lead to particles and forces. These quantum fluctuations may have played a crucial role in the development of the universe, as they would have provided the necessary conditions for the Big Bang to occur. This raises the question of whether the universe could have emerged from a quantum fluctuation, or if it was somehow triggered by these fluctuations. Another interesting aspect of pre-theory about how things came to be revolves around the idea of cosmic recycling. In cyclic cosmology, the universe goes through an endless series of expansions and contractions. After each Big Bang, the universe would eventually collapse back into a singularity before expanding again. This repetitive process could truly mean that the current state of the universe is the latest iteration in an eternal series of cosmic births and deaths. Some scientists suggest that each cycle could lead to slightly different outcomes, with the current configuration of the universe shaped by the conditions of the previous cycle. This idea challenges the notion of a definitive beginning, suggesting instead that the universe is in a constant state of renewal. The possibility of additional dimensions also adds another layer of complexity to how we could interpret what came before the Big Bang. String theory, for example, suggests the existence of extra dimensions beyond the familiar 3 dimensions of space and 1 dimension of time. These additional dimensions could provide an entirely new framework for understanding the universe's origins.